And our second software is Excel Solver. Unlike Lindo, which shows you explicitly your model, your mathematical model, as how you write it, but Excel doesn't have an explicit model writing scheme. First of all, you need to add Excel Solver to your add-ins. It's an add-in that's in the data tab here. We're going to use this one. Now close. First of all, you have to edit in, of course. And how you do it, from Tools menu, you go to Excel add-ins and Solver is there. And I don't think it's different for Windows or Mac. You should be able to download it. If you can't, you just Google it. The steps are really easy. It's not confusing. So we first define our decision variables on an Excel sheet. Let's say x1, x2, and x3. And the values of x1 and x3, x2 and x3 will go here. Let's paint it yellow. Then, so as Excel Solver solves the problem to optimality, which means it will find an optimal solution using simplex algorithm, it will write the optimal values here. Then I define my objective function. And let's say my objective function is called profit. So the coefficients are 20,000, 15,000, and 16,000. Now the thing is, Excel wants you to formalize your objective function and constraints, which means that for each of the constraints and the objective function, you need to have a cell that calculates the value of them. So let's calculate the objective function value. I generally use sum product because it's easier, but let's not start with sum product first. You can do this times this plus this times this plus this times this. So this is a way of calculating your objective function value. But another easier way is you can take the sum product of these three and these three here, which will mean the same thing. So this is your objective function value. This is where you calculate your objective function. Let's paint it red to specify it. You don't need to, it's just for good visualization. Not that I'm a good visualizer or anything, but okay. Then we have the water constraint, and the coefficients are 50, 30, and 30. I'll leave one cell blank, then I write 2000. Or for starters, sorry, for initialization, you could write this is less than or equal to 2000. You don't need to. You will just use this 2000 here. This is for again, better visualization. Then we have the worker constraint. The coefficients are 2, 3, 2. By the way, be careful that we haven't calculated them yet. Less than or equal to 70. And we have the length constraint. The coefficients are 1, 1, 1. And it is the value we will calculate will be less than or equal to 30. I'm going to tell you how to deal with non-negativity constraints later. It's easy. It will be easy. And now, for each constraint, like the objective function here, I should have a cell that has or that has the value of the left-hand side calculated. So the left-hand side for this constraint is the sum product of these coefficients and these decision variables. So 0 is less than 2000. And for the second constraint, I have sum product of these and these cells. And for the third constraint, the coefficients are these and the variables are here. So for example, if I increase x2 by 1, my objective function becomes 15,000, and my first constraint's left-hand side value becomes 30, which means I'm using 30 tons of water or gallons of water. I have 3 workers, or I need 3 workers and 1 acre of land. So you can see that as you change the value of them, the variables, you can see what your objective function is, how much of that constraint you're using. You're using right now 290 gallons of water, and you have a capacity of 200 gallons of water. So let's delete these here. And now I've formalized or calculated the objective function value and the constraints. Now I go to Data tab and go to Solver here. First, it's a set objective. For the set objective part here, I select the cell where I've calculated the objective function value, which is the red cell here. And it says to max min. You will not be using the value of module here, but you will be needing max and min. Here I'm maximizing and it is already selected. If I were to minimize this value, I would have selected this. Right now I'm maximizing. And there is by changing variable cells. Before this part, we have defined to solve Redin where our objective function is defined, or what our objective function is. Here, I define decision variables, which are these 3 yellow cells here. So objective function is defined and decision variables are defined. Now I'm adding constraints by clicking Add. So here, there's a box here that says cell reference. Here you click on the left-hand side of your constraint. My left-hand side is this. 50x1 plus 30x2 plus 30x3 is calculated here. It is less than or equal to this 2000. For my second constraint, I pass on to add here. The left-hand side less than or equal to the right-hand side. For the last constraint, left-hand side less than or equal to right-hand side. Now I have no more constraints to enter. I don't click on add because I have no more constraints to enter. Instead, I click OK. So here you can see our 3 constraints. So objective function, decision variables, constraints. Now we have non-negativity constraints. Non-negativity is provided when you check this make unconstrained variables non-negative box. So I check it. It was already checked. And there is one last thing to do. You don't select GRG nonlinear here. You never do it. You select simplex LP. So objective function, decision variables, constraints, non-negativity constraints, and you're using simplex. And I click solve here. If I keep my solution by clicking this. When I say restore original values, these will be 0, 0, 0 again, but I want to keep the optimal solution. Right now, you haven't learned about the sensitivity analysis, but I'm clicking on these sheets. These 3 sheets will appear here when I click OK. So the optimal solution is here. X1 is 30, X2 is 0, X3 is 0. My objective function value is 600,000. I'm using 1500 gallons of water. I'm using 60 workers and 30 acres of land. Now, unlike S2 and S3, unlike Lindo, you don't see the value of S1, S2, and S3 here. But you can calculate them. S1 is the slack of the first constraint. So when you subtract the left-hand side from the right-hand side, you get the value of your slack. S1 is 500, and S2 is 10, and S3 is 0. I'm using 60 workers, and I have 70. I'm using 30 acres of land, and I have 30 acres of land. I'm using 1500 gallons of water, and I have 2000 gallons of water. So you can read the same thing from the answer report here. The profit is 600,000, and the value of x1 is 30. The original value means that the values in the cells before we ran Excel solver. The cells were empty, so it automatically assigned a 0 there. And now its final or optimized value is 30. X2 and X3 are 0 in the optimized case. So you can find the variables of the slack variables here. Values of the slack variables here. So this is your S1, this is your S2, this is your S3. So you can see that basic variables are X1, S1, and S2. So that's how you solve with Excel Solver.